October 9th, 2022. Every gamma-ray detector on Earth lit up at once. Something was flooding the planet with radiation from 2 billion light-years away. So bright it blinded the instruments designed to measure it. Astronomers called it the Boat. Brightest of all time. A star had just died. And its death released more energy in seconds than our Sun will produce in its entire 10 billion-year lifetime. This wasn't supposed to be possible. The Neil Gehrels Swift Observatory detected it first. Then Fermi. Then dozens of other satellites. Gamma rays, the highest energy light in the universe, pouring into Earth's atmosphere. Lightning detectors in India and Germany went haywire. The burst disturbed Earth's ionosphere for hours, from 2 billion light-years away. Within minutes, observatories worldwide scrambled to point at the source. Gemini South in Chile, Conus Wind, the Chinese InSight, HXMT satellite. Every instrument saturated, overloaded. Picture this. The explosion was so bright it broke the detectors. Astrophysicist Dan Perley at Liverpool, John Moores University, tried to describe it. There is nothing in human experience that comes anywhere remotely close to such an outpouring of energy. Nothing. Eric Burns at Louisiana State University went further. If you took the entire sun and converted all of it into pure energy, it still wouldn't match this event. The brightest gamma-ray burst ever recorded, by a factor of 10. Here is the thing. Gamma-ray bursts happen regularly, a few per week. Most last seconds. Some last minutes. They're violent, catastrophic, but predictable. This one wasn't. GRB2 21009. A lasted 10 minutes of intense emission, then remained detectable for over 10 hours. The afterglow glowed for months. It delivered 6 million gamma-ray photons per second. The previous record holders maxed out at 500,000, 12 times smaller. Some photons reached 18 trillion electron volts. TeV range, the most energetic ever recorded for a gamma-ray burst. For comparison, visible light measures 2 to 3 electron volts. This was trillions of times more energetic. But Swift's X-ray telescope captured something else. Rings. 20 concentric rings of scattered X-rays. Triple the previous record. These rings form when gamma rays interact with interstellar dust. The more rings, the more energetic the burst. 20 rings. Never seen before. But here's the question nobody could answer. Why was it so bright? Gamma-ray bursts come from dying massive stars. The core collapses, forms a black hole. Matter falling empowers twin jets. They blast through the star at nearly light speed. Standard physics. Well understood. Except this burst didn't follow the pattern. For months, astronomers argued about what made GRB 22109A different. Theories multiplied. Maybe the star was unusually massive. Maybe the jets were perfectly aligned with Earth. Maybe we got lucky, caught it at the exact right angle. None of those explanations worked. The burst was too bright, too energetic, too long-lasting. Something fundamental was different. 6 months after the burst, Peter Blanchard at Northwestern University used the James Webb Space Telescope to look at the aftermath. He was searching for the supernova, the exploding star that triggered the gamma-ray burst. He found it, and it was completely ordinary. Wait, what? The brightest gamma-ray burst of all time came from a normal supernova? That doesn't make sense. If the burst was extraordinary, the explosion should be too. More energy, more mass, more violence. It wasn't. The supernova was unremarkable. Average brightness, standard elements, nothing special. It's counterintuitive, Blanchard said. An explosion that produced such a luminous gamma-ray burst produced such an unremarkable supernova. Astronomers expected to find heavy elements, platinum, gold, uranium, the kind of stuff created in extreme explosions. They didn't. The spectrum showed calcium and oxygen, standard supernova material. No heavy elements, none. This raised a bigger question. If extreme gamma-ray bursts don't produce heavy elements, where do they come from? Gold, platinum, all the heavy metals. We thought we knew their origin. Stellar explosions, supernovae, GRB 221009A. A said otherwise. It changed things. The brightest explosion ever recorded taught us we were wrong about where the heaviest elements form. Now, the real puzzle. For decades, astronomers focused on when and where these bursts happened. Almost nobody asked how they got so bright. Gamma-ray bursts release insane energy. But there are physical limits. Jets can't be infinitely powerful. Stars can't collapse infinitely fast. GRB 22. A violated those assumptions. 2023. Brendan O'Connor at George Washington University analyzed the jet structure. What he found changed everything. The jet had an unusual shape, a narrow core, wide sloping wings, different from every other gamma-ray burst. GRB 221009A represents a massive step forward, O'Connor said. The narrow core concentrated energy, focused it, like a laser instead of a flashlight. The wide wings explained the long afterglow. Energy kept radiating for months, longer than any previous burst. This structure is rare, maybe unique. Most jets don't have this geometry. That's why GRB 221009A was so bright. Not because the star was special, because the jet happened to form perfectly. A perfection in a total destruction. Now, July 2024, Maria Edvige Ravasio at Radboud University discovered something else in the Fermi data. An emission line, an energy peak at 12 million electron volts, appearing 5 minutes after the burst, lasting 40 seconds. When I first saw that signal, it gave me goosebumps, Ravasio said. It's the first high-confidence emission line ever seen in 50 years of studying gamma-ray bursts. What caused it? Electron-positron annihilation. Matter meeting antimatter, destroying each other.
If there was an anti-me made out of antimatter, that person in principle could look exactly like me. Same personality quirks, same everything, except of course when I decide to shake his hand. At that point, we both would blow ourselves to smithereens in a gigantic nuclear explosion.
Releasing gamma rays at a precise energy. Antimatter. The jets contained enormous amounts of antimatter. Positrons blasting through space. Colliding with electrons. Annihilating. For half a century, physicists theorized gamma-ray burst jets contained antimatter. GRB 221009A confirmed it. Directly. Unambiguously. We just watched matter and antimatter annihilate. From 2 billion light-years away. GRB 221009A. The boat, brightest of all time. 10 times brighter than any previous gamma-ray burst. Visible for months. Disturbing Earth's atmosphere from 2 billion light-years. Caused by an ordinary supernova with an extraordinary jet. Narrow core, wide wings, perfectly aligned with Earth. It didn't produce heavy elements, forcing us to rethink where gold and platinum come from. It confirmed antimatter in the jets, solving a 50-year question. And it might happen again. Statistical analysis suggests bursts this bright occur once every 10,000 years. We got lucky. Witnessed the brightest explosion in recorded human history. Subscribe for more cosmic extremes like these. Drop a comment. Would you want to observe if another burst this bright happens in your lifetime? The universe has violence we can barely comprehend. The boat proved it.